All right, 276. Now we've seen what happens, how rather it happens that we can declare an array. Now we've seen reading values into an array. It's time to talk about initializing an array. This starts on page 388 for those of you following along. When we declare an array, what C++ does is it goes and sets aside, it goes and sets aside a contiguous block of memory where it can store those values. Really what it's doing is it's locating a memory address here. So that's the start of our array. And then it's just calculating how far out the variable, or the variable, which in this case is going to be an array, how far out that memory addressing for that array has to go. So if we know we have 6 integer array elements, C++ is going to start at a given, wherever it can find contiguous space enough for 24 bytes of data, it's going to set that aside. But just as with all of our other variable types, they are uninitialized by default, which means that any value can be in those storage locations at any time until you specify what those values are. So there can be crap in there from other runs of the program. There can be crap in there from, just compiling and running on a space that's already been filled with stuff. So in order to avoid this, what we want to do is initialize the arrays. So this can be done in a couple of different ways. The first of them here, again, this is on page 388, would be to provide initial values. So you can see it here in the code sample. We have a constant int for months. Is there any reason that we would change the number of months in a year? No. No, we would not do that. So int days, and then inside of our brackets goes months. And what that's going to do is set aside 12 contiguous integer-sized memory slots, essentially, for an array called days. Then inside of our curly braces, we have 31, 38, 31, etc. We have a comma separated list of values. What that is going to do is it is going to provide initial values for the elements in that array. You'll notice here we have 12 months in a year, and we have provided 12 values for our initialization. If, and we can scroll down just a little bit to see this here, I will scroll back up and we'll take a look at the code here. If we provide a partially initialized list, now this is on page 391, we can provide a partially initialized list. What C++ will do is actually fill in the rest of our elements with default data for us. So only when we partially initialize a list. So here in the code sample above, you can see we have an integer array called numbers of size 7. So there are going to be 7 elements in my array. And in my initialization list, I only specify 4 elements to be initialized. What C++ will do, and you can see that right over here next to me, what C++ will do is in those last 3 elements that are unspecified, in those last 3 elements, it will populate with default data 0. So let me tell you what happens here with integers and floating point numbers. Those are initialized to 0. With string data, those are initialized to empty strings, not to 0, but to empty strings. So initialization is important because by now I think like 90% of you have stepped in using an uninitialized value to do math, and what do you end up with? Crazy, crazy results, right? Because that variable, despite the fact that you have declared it, despite the fact that you have told C++, I need this to represent something for my program. You have not told it what the value inside of there is. So when C++ goes to evaluate the stuff that's in there, you get unexpected results. This happens with arrays as well. And the problem is, instead of having just one data element with stuff inside of it, now you have, more, potentially many, many more data elements with all that junk inside of it. So that is something we want to avoid. So we do have two examples. There are actually three examples here. One of them we already walked through partially with integers. Here we can see a similar example with strings. I would have here on, and this is on page 390, I have here on line number 9, I have a string array called planets with size of 9. Now, for most of you, that should be alarming because we really have 8 planets in the solar system and 1 dwarf planet, which is indicated here. But as anybody who has watched the like little Einsteins in the last 20 years here, I have a 7-year-old. This has come up in our family history here. Pluto is no longer a planet. That's okay. Book authors, you can have your opinion too. So after the declaration for the name there, I have the equals, because now what I'm going to do is I'm going to assign these elements. And then inside of my curly braces, I have a comma separated list of string values. Remember, string values all have to be represented with the double quotes there. That's how C++ knows you are providing for it a string. So inside of double quotes is Mercury, comma, then inside of double quotes is Venus, comma, so on and so forth until we get to our dwarf planet, Mercury, or Pluto at the end. Don't read and try and talk at the same time. So our dwarf planet, Pluto, at the end. And then you can see on lines 15 through 16, we are using a for loop to iterate through the elements of our array and output them to our window there. The very last example here works with character values, but I will allow you guys to go ahead and take a look here. We have been saying the following in class probably plenty of times. Let me know if you've heard this before. We progress through the characters as ASCII values, lowercase a through lowercase c, uppercase A through uppercase C, the numbers 0 through 9, and then the characters, the special characters, in that order exclusively. If we want to get to the ASCII code representation of a char value, you can see that we have that here inside of our loop. We are going to display an integer representation of our ASCII characters by iterating through the elements of an array. You can see here char letters, and then number of letters. Here we just have 10. So as we iterate through those characters, we're going to get our integer value by using a static cast. And you can see that right there on line number 19. It appears as though my camera has frozen. It's been one of those days, and we'll meet you on the other side with boundary checking for arrays in C++.